Hopefully everyone is here to talk about Istio multi-cluster stuff. Yeah, okay, I'm in the right place. This wasn't really going to be a talk, so I just have this on because we only have one hand mic, but I'm hoping it's more of a discussion. This room is not really set up for discussion, but so people should like come forward and talk. And I can go through a little bit what we have so far. You guys, actually, you're just wearing the shirt. Is anyone from Cisco here that works on? Yeah. Do you guys want to come up, since you guys probably know more about this than I do? Anyone that wants to talk about multi-cluster, come up here too. We should make this a party. Oh, you just did talk on that. Okay, yeah. So did people here see the demo that they gave of this? No? Do you want to give the demo again? Maybe try it again. So who here is familiar with the multi-cluster work in Istio? Raise your hand if you're familiar with it. Okay, so there's a lot of people who don't even know about it. So I guess we can start with sort of going through what it is. I definitely did not prepare a lot for this. So this is just our docs on the website. These are the preliminary docs. If you go to istio.io and there's a little there's a little gear icon. If you click 0.0 and then you can get some of this stuff. But the basic idea is that we have more than one cluster and you get it all connected, right? So you have a master cluster, and that's where we run the Istio control plane, and then you have a bunch of slave clusters, or remote clusters, I guess we call them. And those just connect to all the services in the main one, and that's how you get all the goodness, right? So this goes through the instructions on how to do this. There's not, unfortunately, any really cool pictures. But basically, you set things up by you have to move a bunch of credentials around so things can talk to each other and load things. But the end of it is that, that's not that useful. There's actually some really good Helm charts for this now that lets you, just using Helm, say, install into this cluster the main and then install into these ones remotes. And then it gets it all set up. And what this actually does for you is a couple different things, right? So one is around traffic management. All the envoys in all of the clusters are talking to the same pilot running in the main cluster. And that one knows about all the different clusters, it knows about all the services, it knows about all the endpoints, and so it can route traffic appropriately. So you don't have to worry about which cluster things are running in. You just say service A is talking to service B, and that same, I want to talk to service B, you can move service B, put it in a different cluster, put it in multiple clusters, right? Multiple clouds. None of the clients change, they all just still talk to it. So that's probably the biggest benefit. The other thing this gives you is the authentication part. So mutual TLS works across the clusters, assuming they're all on the same network. There's ongoing work to work on more network support. And then because you're sending everything to one cluster in terms of observability, the Grafana dashboard is for the entire mesh. It's not for a single cluster. So you get, you can see all the traffic for that service no matter where it runs. So that's the basic stuff. Let's actually talk about stuff unless people want to see the demo. I want to get questions and discussion because that's what this is supposed to be. So, do you want to pass out? Anyone have questions or things they want to talk about? You can.
Hello. Yeah, so I have a question, I guess, for the audience, because this has been something we've debated in the community a bunch of times. This model has a single control plane, and all the remote clusters are communicating with that single control plane. A single pilot. Let's call it a single pilot. Is that the model that people really want? Because another model that we had started to implement, and then we've gotten a little delayed implementing, and we probably will implement, is where you have a more of a federation. Federation might not be the best word, but a federation of pilots, and the pilots talk to each other, okay, and interchange the service and endpoint. So each pilot talks locally to its service registry. It's Kube API if it's Kubernetes, and then they exchange information. So that's another model that we've explored, and I guess we'd be interested in feedback. Is do people have a preference, or do people have an idea what they prefer? As Sven mentioned, the other one is the Grafana dashboard in the mixer. There's been some discussion about mixer scale and how chatty it is. Another model that we're likely to try to implement is where the mixer, maybe we have a common pilot, but we actually have a mixer in each cluster. The mixer maybe have a ubiquitous view of all the service and endpoints, but as far as telemetry collection and rules and stuff like that, everything's done to a single, each cluster has its own mixer instantiation so that we spread the scale across the clusters. So just if people have feedback or thoughts on,
Yeah, yes. Yeah, this is a discussion. You guys, everyone should move forward. I don't know why you're all sitting way back there.
So we're going to use MultiCluster to avoid one etcd being down, or etcd being down, hitting all availability zones. So I think we would like to not have only pilot in one.
Yeah, and on the pilot side, one of the things that we've been talking about recently is there's sort of two models for having pilots in each cluster, right? So one model would be what you were talking about, where each pilot in each cluster is like talking to its local registries and getting the information. Another model is you still have this model where you have like a main cluster, and that one knows about everything, and you just run that HA, right? You run that across multiple clusters. So you could run that in 3 of your 20 clusters, right? Not necessarily one in every single one, but you run it in 3 of them, and that's sort of a single pilot HA, right, across all the clusters, or across 3 clusters.
That's been a common theme in any of the multi-cluster discussions I've heard, which is people say, what about HA? If you have a single pilot, you don't have a very good HA story. So that's, perhaps the best way to achieve that.
Yeah. And I think Mixer is maybe a little bit weirder in that sense, but I think we could maybe do something similar for that, where you kind of think of it as one mixer running in some of your clusters, rather than thinking about it as a federation of mixers.
Yeah.
But it sort of depends on how you think about it.
I can speak up.
Yeah.
So are you guys thinking of moving to the federated model eventually, and this was done just for expediency?
That's a great question, because I think we haven't really figured that out, and that's partly why we're asking, right? Is because when we originally designed this stuff, the federation model was what we were thinking, and we spent a lot of time trying to figure that out and getting it working, and then it was like, wait, we can just do this much simpler thing, which is just run one and have it know about everything, because actually we already had the code to do that, because we already had to support multiple registries of services, because we supported console and we supported Cube API.
Yeah, that's exactly right. This was very simple to get started with, extremely simple, because we already had the code was already modularized to, handle Kubernetes, console, all those, even in a single installation. So we were just able to expand it very simply. The federated approach was a little bit more complicated. We had quite a bit of debates, and we actually started doing some work on it, but we got busy with really improving quality, so it's been slow.
But yeah, I think that the good question is, what do we do, right? If this is this good enough, what we have already? If it can scale to, I don't know, 100,000 services, 1 million services, why even do federation, right?
Yeah, we in the federated model, the work that they've been doing for Federation v2, it actually would help a lot for the deployment case, so where you're deploying the services into the mesh. And not so much, the work we've done already could coexist with that actually. So the pilot knowing about all the, everything in both meshes or multiple meshes is already there. The addition, it would be cleaner if you directly use the same cluster registry and stuff that's in Federation v2. But as far as, after you've deployed Istio, what do you do to deploy your apps across multiple clusters? And Federation is trying to solve that. They've got some great primitives they've already demoed this conference, so you don't have to have homogeneous clusters for deployment, and that's the target we were going for. So when we were looking at Federation v1, we ran in, like Sven said, we ran into problems, and we just we looked at the architecture of Pilot and said, oh, it's easier just to do this, and it works. So
yeah, and I think there's to try to clarify things, there's Kubernetes federation,
right.
And then there's the notion of federation of pilots, which I think is slightly different. So just make sure
so when I said Federation v2, I'm referring to Kubernetes federation.
Yeah. And I think they unfortunately do play together. And one of the big problems with Kubernetes federation is it doesn't solve the problems we were trying to solve with the Istio multi-cluster work. And at least I think that's a lot of what people want to solve, right? Like, I want to be able to move an application between different clusters and have all that work. And I guess they were going to solve it at the service level, but not at like L7 level. So there was another comment question. Right, so I think there's basically two models that could work here, right? For both pilot and mixer. So there's two models that would work. One model is you run that in every single cluster and they federate, and when I was saying federation, that's what I meant. Not Kubernetes federation, but like our federation of the pilots, each pilot or each mixer only knows stuff locally. It doesn't know about everything, it just knows its own stuff and it knows about the other instances, not the other instances of itself, but the things it's federated with, right? So you have a pilot in cluster A, it knows all the stuff in cluster A. You have a pilot in cluster B, it knows everything in B, and they talk to each other and they exchange information. So that's one model. Another model is you just say, I'm only running one kind of logical mixer or one kind of logical pilot, but I run it HA in multiple availability zones. So I'm running it in multiple clusters, but it's still kind of the same instance, right? Each of those has full information about everything. Each of them's talking to everything. They're not talking to each other. They're all getting the information. So either of those models would work. And I think we're trying to figure out which model is better. And I think, like originally our design was the federation one that they're all talking to each other. I'm starting to think we don't even need to bother with that. But that would be it, yeah. Right, so that's what I kind of meant by the HA version of that. Yeah, so you say I'm going to run pilot in these 5 clusters, but every one of those is kind of a master pilot. Yeah, and I think that works. So I think that's probably where we'll end up. At least that seems like where the conversations have been going as far as I've been hearing it. So, but mixer is maybe a little trickier. Actually, mixer there's a bug, maybe you'd say, in the multi-cluster support, because mixer right now actually gets information from the cluster it runs in about some of the stuff being called, like some of the labels and things, and so none of that works right now in multi-cluster. Like it's missing information because it doesn't know how to get it, so we have to solve that. But go ahead. So if you had, I don't know, 1,000 clusters, I could see only running in 100 of them. It depends on your scale and what you're doing, right, and what you need. Well, so separate clusters in the same mesh, right? So not different meshes, but yeah, the same mesh. So that's like, yeah, it depends on what you're doing. But I think the first thing we need to fix is making sure that you could run it in every single one, but it's all kind of one logical one. It's all the main. And then it's, ideally if we do that right, then it's just up to the user, right? It's up to you to decide how many clusters you want to run in. You can run in all of them, you can run in some of them. We're actually already looking at this per node, a per node option, right, for Mixer. So you could scale from like, I'm running a single instance of Mixer across my entire mesh to I'm running a Mixer on every single node in my mesh. And we can make that all work everywhere. And then if I make that work, then I'm like, it's not my problem, right? It's best practices. But.
I feel like you're never going to want to deploy less than one mixer. Just because there's already so much overhead in having a Kubernetes cluster that having a mixer process one per cluster is already.
It's pretty cheap.
And it gives you significant latency benefits on check calls.
Right.
But I do think as soon as we have mixers in separate fault domains, we need to be very, very, very careful with the implementation of adapters. Because things like quota checking and rate limiting need to work locally, even though there's 20 mixers that maybe can't run.
Yeah, I think.
I think that's a good point.
I think that's the big problem, because when we started Mixer right now isn't. It's fairly easy for us to do what we did to pilot to Mixer, so that, like as Sven said, some of the requests and stuff aren't properly mapped. Fixing that problem is easy. But the reason we didn't do that, as obviously, is because of exactly some of the reasons you said. There's a lot of latency if you're carrying that traffic across, and it's not as obvious that if you run a mixer in every cluster, it's not as obvious how you handle the quotas and the rate limits.
Yeah. Yeah. Do you want?
Sorry, I just said that you really need a mixer in each cluster because of latency reasons, even if you forget availability reasons. But as soon as you have mixers in different fault domains, you have a huge problem with enforcing global things like rate limits, quotas, etc.
Yeah, so I think taking the two parts of that, the first part, that's probably true. I think there is a scale point where maybe you don't run it everywhere. Like internally, we have an equivalent of mixer. We run it in every single sort of zone, availability zone, basically, but not in every single cell, every single cluster. But that's because we have so many, right? There's so many different clusters. So I think that's, as you get to like, if you have 100,000 clusters, right? Like you have like 5 in the same building, like, do you really need a mixer in everyone? Maybe you do, maybe we make it easier, I don't know. I think the second part is probably really something we need to think about more. Just how do we deal with, in general, adapters. So the one of the models for mixer that we've been pushing people towards is that adapters shouldn't do work. They should mostly talk to a backend that does the work. But then you're punting the problem to the backend. So now the backend has to deal with the fact that, okay, it's running behind mixers running in like 10 different clusters, right? So if it's Prometheus, do you have all those mixers talk to one Prometheus in one cluster? Do you run Prometheus in every cluster and have them all talk, and then I don't know what, and then you have to solve this. Yeah, you punted the problem, right? We pushed the problem to Prometheus. Quota is harder. Yep. So if you're running quota and all, then you have to have a globally scaled quota.
Actually, we
Auth's not too bad, I think.
Yeah, the way we solved that, initially we did this without auth, but recently we've added auth, so you have a Istio Citadel in every cluster, all chained to the same root certificate. So that's actually how we're handling auth.
So for the identities.
Yes.
Yeah. So identity, I think we have a pretty good model there. The authorization is where the check call would come in, and that's fine because that's a local decision, or it should be a local decision. So again, it's only if you're talking to, so quota is a great example. Quota is a lot harder, especially if you want global quotas. Whatever quota system you're using is going to have to solve that, right? Like we're not going to solve that in Mixer. I think whatever you're using, either you're going to run it in one place or you're going to run it across multiple places, and the implementation of that has to figure out how to do that.
I think at a bare minimum, if you're not going to deal with it in Mixer, you should let adapters declare whether they support multi-cluster Istio, and if not, you should have them actually refuse to start up configurations.
That's an interesting idea. Yeah.
Just because otherwise someone is definitely going to shoot themselves in the foot.
Yeah. Well, I think some of them, if you only run, so if you do the I'm running Mixer in one cluster, I have 10 clusters, but I only run it in the one, I think most things would work. And then, the question is, okay, so if you're running in a multi...
Really, it's if you have more than one Mixer.
Yeah. We actually already have that problem with quota because of, so the initial quota implementation only worked if you had one instance of Mixer, not just one cluster, but a single instance. Did we push out a new one? Anyone here know? If we were building a new one, but then we stopped, and I don't know. I don't know the current state. Yeah, it doesn't seem like there's a good quota, open source quota implementation out there for us to use. But yeah. More things to talk about. People want to know what's on the roadmap. Yeah. Yes. Yeah. Networking is a great thing topic.
Yeah.
Yes. Yep.
Yes, there's a couple projects. There's some called Zero VPN, which was a design spec that was attempting to address that, and we haven't gotten too far on implementing it, but it's up there. It's it's on the Istio, the public drive that you can go take a look. But yeah, we would clearly like to solve that.
Yeah, and it's that work is actually helped by a lot of work happening in the networking working group around the new APIs. So there's a bunch of new networking APIs. One of those is this gateway thing. And we think we can repurpose a lot of the code we're writing for Gateway to set up a tunnel between different, basically, it's a VPN, but don't call it VPN, between different clusters and have, so gateways talking to each other, and then that bridges it, and then you can bridge them. And then the problem is you have to be able to tell, so if you're using a single pilot, you have to tell that pilot which network you're part of. So it can segregate IPs by network, and then it can tell you, oh, okay, you're in network A, the thing you're trying to talk to is in network B at some IP address. Okay, you actually have to go to the gateway first to get through it, and yeah. So setting that up is interesting, but we can make it work. There's a bunch of options for that in the doc. In the doc, we list probably 4 or 5 different options for how to do that. You can do it end-to-end using SNI sniffing to route the traffic. There's some other options where you don't do it end-to-end, but I think end-to-end is preferred.
So for the gateway, you don't find any external IPs for the gateways? Why is it called gateway then?
So no, the gateway has to have an external IP.
Then if it has external IP, then the external IP is routable between the clusters.
Right,
So
right,
you need to
but
create a tunnel between them.
right, it's a tunnel, exactly.
I mean, you don't need a tunnel. You're
saying why do you need a tunnel?
Well, so it's you tunnel through that gateway. It's not.
Oh, you mean a tunnel through the gateway?
Right, so it's not a traditional VPN, right? It doesn't look like you're on one network. It's just, it has the effect of a VPN where things can talk to each other. But yeah, so you bounce through the gateway, right? So VPNs try to make this sort of hidden, right? But because we control the ends with the envoys, we don't have to actually hide that fact, right? The envoy will, to the application, it looks like a VPN. To the mesh, it's not. It's envoy talking to gateway talking to envoy.
Just on that
Does that make
spec,
sense?
do you know if the any of the solutions preserve? So in the load balancing that Envoy does, right? It makes the decision at the sender of the endpoint it wants to hit, and it does that based on all the properties of the pod, right? Not anything else. So if it goes through the gateway, is that decision going to be preserved by any of the approaches that we're talking about?
Yeah, I
that's
think
one of the reasons we really push to just go to all pod connectivity. So.
Right, I think that, so yes, we have to solve that, absolutely, and we've talked a lot about it. I don't know if there's been a decision, just because we haven't pushed on it too much, but there's a bunch of ideas for how to solve that. So yes, you pass some of the metadata. So you're calling a gateway, but you're telling it, I actually want to talk to this pod, right? So the envoy can communicate who it actually wants to talk to at the other end, and then the gateway can forward it appropriately. So you could do that using SNI, you would basically have kind of a mangled domain as the destination, and the gateway would sort of unpack that and change it on the next hop or whatever. So yeah, there's ways to do it to get that end-to-end behavior. So then you get you're basically multiplexing through the gateway, right? I think you can do it.
Yeah, can you talk a little bit about how you can use this work with one Kubernetes cluster on one side and something else on the other side, like my old school VMware infra and where I have installed Istio? Can I just use the same principle to
Yes.
make everything talk to each other?
Yeah, the principles, that's the different topic called mesh expansion instead of multi-cluster. The principles are pretty much the same. You have something like the components of a sidecar running on your virtual machine, basically the Istio proxy, which runs Envoy underneath, and then you export all your certificates, and there's a lot of manual things to be done right now where you need to populate your routes to go to that, and then you need to populate, or you need to tell it what the endpoints look like where is pilot and where is mixer. And yeah, beyond that, it's just the sidecars on the virtual sidecar on your VM and the real sidecar on your pilot. They're going to make a connection and the traffic will be seamless. And then you still need to manually register the endpoint using Istio CTL on the Kubernetes side. But after all these steps are done, it looks like it's just another endpoint. It's like a headless endpoint.
Yeah.
On that, can you deliver something that will set the IP tables just like it would do on containers? Because one of the concerns we have is, oh, hey, now we have this VM and we add this sidecar. We used to have end-to-end TLS, and now we put a sidecar on the VM, and suddenly we have, no TLS in between. And you use IP tables and stuff to prevent things flowing out. Can we get that as well, or should we do that manually as well?
So I think this is all about mesh expansion stuff, and just VM support in general. Right now it's pretty manual. I think we provide some scripts to make it easier. I want to invest a lot more in making that better. I think it's really important to make that easier. We kind of got it. We got it so cheap in Kubernetes because of the way things are set up, but that it's like, oh, if you want to do this on a VM, run this script that does like 40 things, like, make sure you have DNS mask, like all the stuff that you have to do, and it's pretty hairy. I think making that better is one of our big emphasis, but I don't have a good solution yet.
Yeah, I mean, some of your IP tables will be set up by the proxy and Envoy running on the VM. The TLS mode, I had some trouble getting it to work, the MTLS as a VM to pod connectivity. Maybe I'll give it a shot again with the latest release and confirm if it works.
I just went to a talk actually before this about Cilium. I don't know if anyone here was there, but they had their talk was about how you can get rid of IP tables and use something better much faster. So there's some really cool stuff we can do there too. There's also the VPP stuff that should be possible to do this. So there's a lot of really interesting things coming down that will make the whole Istio mesh a lot faster and also more secure and also simpler to set up. So yeah, win-win-win.
Do you see common work between this multi-cluster Istio and the seed multi-cluster group, for example, a cluster registry to manage Istio itself?
Yes. So we've been on and off talking to them. You can go in more detail.
So
Yeah.
in fact, one of the key things to implement multi-cluster is we need to know what clusters you want to connect. And we started from using SIG multi-cluster work, but at the time that we attempted to do this, I don't think they were quite ready. The goal was that we would do that via an API call. The pilot would call the cluster registry and say, give me which clusters you want to make a mesh out of, and it could be multiple. Okay, we didn't get there, so right now what we did, what you see now in the current Istio is you see flags that say cluster registry, but it's just a file. And our best guess at the format of the cluster registry spec at the time that we implemented it. But that's, the vision here would be that we would use that work and we would drive pilot from the cluster registry.
Right.
Yeah,
Yes.
yeah, but I mean, there's also the cluster registry also has to solidify and show, people show momentum and commitment to doing that. So that was also the doubt.
And I spent a fair amount of time talking to at least at Google, the leads of the multi-cluster work. And so we're pretty much in sync on a lot of this stuff. They know what we're doing, we know what they're doing. And it's, over time, more things will converge. There's a bunch of interesting questions, like there's the multi-cluster ingress work, and Istio can kind of do the same thing. And so there's like, how many of these things, the big question is how many of the things that we can do they build? Or do they just say, well, Istio just does that. Let's just tell people to use Istio, right? So I think that's an open conversation, and some of it's around, Istio wasn't ready, and like they're not ready, and so it's we don't want to slow everything down by forcing an alignment early, but I think everyone is interested in having one good story, right, and not telling people confusing things. So we have here and then back there.
So I think there's sort of two big applications for multi-cluster Istio, and we've sort of touched on them, but we haven't really talked about how they're separate and sort of have different needs. One big application is the hybrid case where I have some application maybe on-prem running in VMs or whatever, and I want to slowly migrate it to the cloud or build out new features in the cloud. And so I would sort of say that that's really a single application that's spanning multiple clusters. And then I think the other application we talked about when we mentioned things like fault domains, availability zones, is running the same application in a fault-tolerant way, or maybe even you might think of it as n copies of the application in a fault-tolerant way, where every cluster has the same set of workloads running in it. And I'm curious, like, if I could maybe poll the room or something, is there a particular one of those two that you're more interested in? Because I think that they need a lot of different features from Istio.
Yeah, so who's interested in running sort of different parts of an application in different clusters or different clouds?
It's going to be 50-50, isn't it?
Yeah. Well, some people should well, you can answer both if you're interested in both. Yeah, so what about I want to sort of HA across the world, across multiple clusters. Who's interested in that?
I think that is about 50-50. Well, that's good.
Yeah, okay. Yeah, so
I mean, mostly the thing I'm interested in is whether individual services are likely to be backed by sets of pods running in multiple clusters, or whether each service is likely to live in one place. Because things like load balancing get more complicated. For example, I think right now we don't quite yet have geographic aware load balancing, for example.
Yeah,
if you want to run something in multiple places, you need that. You need to think really hard about your monitoring to try and understand geographic monitoring of a service. That's all sorts of things get more complicated in that world.
Someone was going to say something.
Mm-hmm. I mean, one of the things I was wondering is if you're in that sort of second case where you're running an application around the world, I wonder if you really probably should have separate meshes and not a single mesh.
I hope not, because the way we're trying to model that is one mesh. That's actually, so that was supposed to be one of the key use cases for multi-cluster, is exactly that.
Okay.
And yeah, you're right, we don't yet have the geographical aware routing, but that's coming soon, hopefully.
Yeah, I mean, for example, a common way to deploy things, maybe that's just because Istio is not very popular, but a common way to deploy things today would be you have front ends that are sort of globally load balanced, and then your service within a cluster is configured to only talk to backends within the cluster for latency reasons, or just because that's easy. Yep. And so I wonder if in the future we actually will still have that model, even if Istio can see everything, maybe it doesn't need to.
Yeah, no, I don't think so. I think people will move to the model we do at Google, right, is that you prefer local, but if local is loaded and some other cluster nearby is not loaded, you fall over there, right, and you call that. And that has a lot of benefits. Obviously, you have cascading failures because of that, but there's a lot of benefits to that too. So I think people will get there. I don't think they'll stay in the each cluster is an isolated cluster. And the Kubernetes Federation is kind of targeting this a little bit also, right, in terms of deploying to these. The model is that you deploy the same thing across multiple clusters. So I think there's definitely an appetite for it. You had a comment or a question back there, yeah?
Multi-cluster. Are there any trade-offs to be made depending on where you put Istio auth in multiple clusters?
Yeah, so I think there's, and you can correct me if I'm wrong here too on this, there's sort of two models for how to do this. One model is, I think that I don't know if we call this a hack or not, but the way we set it up now was that you basically copy the key material and have, it's basically like a distributed CA. So you have a distributed root CA in some sense. Another model is to actually have a real root CA and then have intermediate CAs in the different clusters. I think both of those can work. Probably the intermediate is more the right way to do things. I'm not sure if we have that all set up. Do you know the current state of that? Yeah, so it's the security team is working on that, but it's both work, and they know about that and they're working on it. But yeah, the model is that you decide where your root CA is, you have your root CA set up, and then you have sort of cluster CAs that are intermediate. And then they all share a root of trust. The identities are consistent across the mesh, and it all just works.
Perfect.
Yeah, so the question is scaling problems, right? Like scaling as the number of things in the system grow. So I think we're somewhat confident that Pilot can scale pretty high. I think that would be where, well, so even if you switch between the federated model and the global model, that doesn't help much because in both of those models, Pilot is supposed to keep the entire mesh in memory, basically. But at what point does that fall down? And if it's, 1 million endpoints, maybe that's okay because nobody's going to hit that. But yeah, there are scaling limits. Obviously, you're going to hit them at some point, and the question is when. Yeah, so I think there's a bunch of different limits here. We'll hit that earlier.
Yeah, so,
Yeah.
yeah, with respect to pilot, some of the scaling that we're seeing and we're trying to improve are less about, multi-cluster and how many clusters, but more about the number of endpoints, how much you have changed, what kind of protocol you're running V1 versus V2 to Envoy, those kind of things. So the scale stress points so far don't seem to be the number of clusters, it's the number of the other resources. And
Yeah. So like one big cluster versus a bunch of small clusters doesn't make much difference here, right? It's just the total mesh size that matters. Yeah. Yeah. And we're actually out of time if people, but we're happy. I'm happy to keep talking. I have nowhere to be, so we can keep taking questions, comments, thoughts. Anything else we should ask the audience before they all leave? How many people are interested in using this once it's ready? Okay, good. People are already using it. Okay, awesome.
Yeah, there's just, if you want to get involved, we're happy to have you. And even if you just want to try it and write up issues, we're happy to hear them.
So I'm like crazily enthusiastic and overexcited about this area just because it's something that's so cool once you get used to it, and it's like getting people to understand like you don't have to worry about getting everything set up the same. You can run things in different places. You can migrate them. You can move them around. Like, oh, I need to spin up a new thing in a new region. You just spin it up and it works, right? Like that level of just awesomeness is what we're hoping to get to. So I'm excited.
The same. I think the service will have to be named the same way, the clusters, same namespaces, and so on. So maybe
Yeah.
not in the same infrastructure, but at least the logic definition of services is going to be.
Yes. Yes, you do have to use the same name. We talked a lot actually early when we were starting to design this stuff. Originally we were going to do all this aliasing and like you'd have a mesh name for things versus the local name, and those could be different. We may have to go there at some point where like if for some reason you named the same thing in different clusters, different things but the same name, and then you want to merge them, like yeah. So we haven't really tackled that yet. Maybe it'll force us to deal with it. So I don't know how. Do people here have like front end and default namespace in different clusters that mean different things? I don't know who's using multiple clusters. Like, do people tend to name things consistently, hopefully? Because if so, you can use this. If not, it's going to be painful. But yep, yeah. So actually, that kind of stuff is going to be interesting. Yep. Yeah, because you don't want Mixer to call into a different clusters from Prometheus if it's trying to get local data. Yeah. Yeah. So we talked a lot about that use case. Yep. Yeah, and we talked about that, whether that's a whitelist or a blacklist, right? Like, so do you say default everything versus, having to actually like mark it? So one thing we talked about earlier was like you'd mark it with the name and then it would be exposed. So that's an option. We can add that kind of stuff.
Yeah, that's actually something that we've started to like kind of lay out how we might do it, but we need input on exactly what the requirements are too.
Yeah, that's exactly right.
Because it's very, it's wide open how you want to you do that. You really need some application, expertise to say how they might want to handle that filtering.
Yeah. Yeah, and another idea is just there was work on this thing called Bring Your Own Name, and I think that kind of fits in here nicely where it basically lets you rename things in the mesh, and so you can use that as the mechanism, and so we could say, oh, only if it has that annotation giving it a name is it exposed. Another thing would be you could do the opposite, where you, like maybe on the Prometheus example, you say, annotate this as a cluster local resource of some sort, a cluster local service, and then it has a cluster, it has no mesh name, or maybe it has in the mesh name, it's actually, you have to qualify it by the cluster or something. And by default, people can't connect, or, I don't know. There's lots of interesting things we can do there. In the same cluster. Configuring it, yeah. So maybe you can do that. You say, don't waterfall. Yeah, only connect locally. Yeah, that would be another way to do it. Yeah. So Pilot would tell it. So once we have that part, Pilot will be telling Envoy, hey, to talk to this service, there's actually 5 IPs behind this gateway, right? So you have to give it a weight so it knows how to load balance to it. You need to give it the region, but then you also tell it, yeah, it's going through the gateway, here's the gateway IP. No, all the envoys would know that information. So Pilot programs all the envoys, and then Envoy would say, so Envoy knows to talk to service X, I have 3 IPs locally, I have another 5 behind this gateway and another 6 behind this other gateway. And then, it would prefer local depending on the configuration. And then if that local is overloaded, it would try to find the closest one to talk to, right? And then it would load that based on how much load it can take, and that's based on how much is behind it. Yeah. Thankfully, we have a ton of experience doing this, so we know, at least know a lot of the traps ahead of time, but yeah. Well, the gateway thing's new, actually. But.
So I lost track of whether the egress proxy is coming back or not.
The egress?
Yeah, there used to be an egress proxy, and
Yep.
depending on if that is resurrected, it's going to be.
Yeah, do you know, anyone know the latest status on that? Is it back in?
If you have an egress proxy,
It's optional though, right? Yeah. 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 And that's the way it should be. And I think, yeah, so I assume and hope that it will work the same with Zero VPN. You could require it to be that, like, I guess that's 3 hops, or you could support 2 hops, right? So if you have connectivity to the gateway on the other side, you could go directly, or you could go through your egress. You could also, yeah, it depends. You could do something, I don't know, you might be able to do something where the egresses are the gateways are on each other's network somehow, and then you'd actually have 1 hop, and I don't know. There's lots of things you can do to make this reduce hops, but I think the theory is if you're going cross cluster, you're probably paying a higher price anyway. So cool. Yeah, last questions? No, we're already 10 minutes over. Thank you guys all for coming. That's fun. Okay.